Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. We need to differentiate 4 compounds: m-nitrophenol, weak acid, m-nitrobenzoic acid, stronger acid, m-nitroaniline, base, and m-dinitrobenzene, neutral, using 3 reagents in decreasing order of their differentiating ability. Moving on to the next step. M-nitrobenzoic acid, strong enough acid to react with NiHCO3, pK 3.5, reacts with both NaOH and NiHCO3. M-nitrophenol, weak acid, pK 8.4, reacts with NaOH but not with NiHCO3. M-nitroaniline, base, reacts with HCl, forms ammonium salt. M-dinitrobenzene, neutral, does not react with NaOH, NiHCO3 or HCl. Moving on to the next step. First reagent NiHCO3, only m-nitrobenzoic acid reacts, gives CHO to effervescence. This separates the carboxylic acid from the rest. Second reagent NaOH, m-nitrophenol reacts, dissolves in NaOH, but m-nitroaniline and n-dinitrobenzene do not. This separates the phenol. Third reagent HCl, m-nitroaniline reacts with HCl, basic amine forms salt and dissolves. M-dinitrobenzene does not react. This separates the amine from the neutral compound. And for the final step, the order NiHCO3, NaOH, HCl corresponds to option C. Option A, NaOH first would react with both the carboxylic acid and phenol simultaneously, not distinguishing them cleanly in decreasing order of reactivity. Option B, HCl first only identifies the amine, but carboxylic acid and phenol, stronger acids, should be identified before the base. Option D, NaOH first again does not use the most selective, NiHCO3, reagent first. The correct decreasing order of reagent strength selectivity for differentiation is NiHCO3 reacts only with strongest acid, carboxylic acid, then NaOH reacts with weaker acid, phenol, then HCl reacts with base, aniline, leaving the neutral compound unreacted throughout. Therefore, the correct answer is C. Therefore, the correct answer is option C.